And we have the, I believe, last paper of this session before the discussions and questions. Is Anurag Gupta from DAV Indore. He shall speak on gasification, sources and energy. Anurag, please.
Okay. Good afternoon, everybody. Since our presentation is in two parts, so first part will be covered by my colleague Sanjali Jain. So I just want to invite him.
Good afternoon to one and all. I am Sanjali Jain with Anurag Gupta from Institute of Engineering and Technology, DAV Indore. We are here to talk about the concept of municipal bio-waste gasification source of energy and its financial aspect. The topics we are going to cover in today's presentation are gasification technology, experimental results, policy implications, and its application. The aim of our project is to combat the energy crisis through optimum utilization of MSW using gasification as a tool. Talking about the Indian scene, where 920 million tons of waste is generated every year, and out of which 840 million tons of waste is openly dumped, solid waste management becomes a challenge in Indian scene. Here we are left with two options. Either extract the energy from the mixed waste, which contains toxic and inert material and significantly low calorific value, or process it beforehand before mixing it. Also, one of the most compelling challenges which the 21st century faces is to extract energy and meet the national and global demands while minimizing the impact on environment. Gasification is what we suggest and can help us meet those challenges. What is gasification? Gasification is a clean technology which converts any carbon-rich material, such as biomass, into producer gas, which can further be used as cooking gas. Now the question is, why only gasification? RDF, which contains low calorific value, makes it difficult to utilize it for the energy extraction. Biomethanation, which requires pure organic waste, at feedstock, which is the only major challenge in the Indian scenario. Coming to incineration, the emission of air pollutants such as ash contents and etc. further deteriorates the atmosphere, whereas landfill requires large and secluded areas. And biocomposting, heavy metals enter into the food chain. What exactly the gasification process is? The waste is collected from the college or garden waste or agricultural waste which can further be put into the reactors in a dry state in the limited amount of oxygen, from where it goes to the cyclone condenser where it is cooled, and from there it goes to the filters, filter 1, filter 2 and filter 3, from where the tar is separated out. Now here the tar which comes out can further be used for as manure and also can be used for the road construction. So the byproduct is itself useful. Now once the gas is produced, it goes to the burner where it can be used as cooking gas. Here I would like to bring into the notice that filter 1, filter 2 and fabric filter consist of waste itself. Filter 1 and filter 2 consist of biomass, and the fabric filter consists of the fabric waste. So ultimately it is an integrated system which processes waste and which is made up of waste. Coming to the results, within 12 minutes, flammable producer gas can be produced, and the gas flow rate is around 10 to 12 meter cube per hour. Uniqueness of the technology is it is portable in nature. Any type of biomass can be used as fuel. It is inexpensive compared to other technology on a small scale level, and we are suggesting this technology on a small scale level itself. And it can work anytime in 24 hours in a day, and the products and the byproducts are useful, so it makes a viable concept. For the financial aspect, I would ask Anurag to continue.
Okay. Good afternoon, everyone. I would like to expand on the financial aspect and policy implementation of this project. As discussed earlier, that gasification is a technology which is well applied in the areas of mass cooking. So we have chosen an area which is a government scheme called as midday meal scheme. It is an initiative taken by Government of India where the cooked meal is provided to the children of primary and upper primary students. It aims to prevent the classroom hunger, and it basically aims to improve the nutritional status of the poor students who are unable to get down the good meal. Now, there are a few major problems which these government schools are facing. Firstly is the lack of availability of fuel. That is what we are talking about is LPG cylinders. Second thing is that the cook cum helpers who are cooking the food, they are unable to manage the cost of LPG cylinders within the budget given by the government. And the last, which is the major problem which Government of India is facing, that after the removal of subsidy from the LPG cylinder, an extra burden of 752 crore rupees came on this program. So what are those initial steps can be taken to start solving this problem from a small scale level? Formulating a pilot project which covers at least 10 government schools in urban area. It basically aims to put a single gasification unit in each school, and the project should be applied in those urban areas where the biomass is available in abundance so that the whole process works very well over there. If we talk about a policy, then the system we are proposing here is a biomass gasifier community stove of 12 kilowatt capacity of thermal output in 100% gas mode. If we talk about it financial aspect, the cost of one gasifier unit is about rupees 50,000, and the operation and maintenance cost which is being calculated is about 1200 per month. So now the waste which we required is the bio-waste. The collection of rate of the bio-waste is about rupees 1 per kg. Now how this 1 rupee is being distinguished here? The 50 paisa we are giving to municipal corporation, and 50 paisa is being given to the labor for the collection of waste. Now moving towards the financial assessment, after doing the assessment in 5 urban schools, we get to know that having an average size of 200 students in a school who are getting this meal, and it is being seen that an average of 5 LPG cylinders are used per month to cook the food, which cost around 5,500 rupees per month. The bio-waste required for daily operation is about 12 kg. So in this way, if we talk about the total monthly investment on my one gasifier unit is about 1,500 rupees, which totally involves the operation and maintenance cost plus the fuel cost. So in this way, if we calculate the whole savings, so savings from LPG replacement, my gasifier replaces the LPG of rupees 4,000 per month. So it brings the break-even point of my technology in just 12.5 months. Now, so what after payback period? Now this is what we have talked before the payback period. After 12.5 months, now before that I want to add something here. That government reports, that midday meal report says that every year the cooking cost per meal increases by 7.5%. So from here we have seen that in one school, the cooking expenditure during the payback period increases from 1,77,000 rupees to 1,90,000 rupees after payback period. And recent trend shows that the LPG prices is on continuously high. So we can say that our saving is also increases. So after payback period, the saving increases to rupees 44,000 per year. So in this way, if we talk about the total money saved from my LPG replacement, if I implement this gasification technology, is about rupees 44,000, which is the 23% of the total cooking cost. Thus, I'm applying this technology to save about 23% of the cost of the government which they give it to the schools. In this way, we are saving this much amount of money. So applying the same type of model in 10 urban schools, which we are talking about a pilot project, it saves around approximately 500 LPG cylinders in 1 year. and the total money saved from LPG replacement is about 4,41,000 rupees. And one of the most important thing that why we are focusing on this type of technology at a small scale level, it saves the valuable municipal biomass which is getting to mix with the urban waste, because whatever happens in city is that when it is get down after the premises, it get totally mixed with the waste, urban waste, and it loses its energy capacity. Like we will not be able to exploit it in proper manner. So in this way, this whole project apply. Summing up all this, the gasification technology is well applied at a small scale level. It not only improves the waste management system at a small scale, but it also solves our problem of energy crisis. So, and on the other hand side, that we are applying this type of projects in the school. So this is also spreading awareness among the students, that the students have to start segregating the waste at source, and to utilize, to know the importance of waste they are producing, to utilize them in proper manner, so to get down the energy from it. So this all from our presentation. Thank you.
Thank you, Anurag. Wonderful presentation by both of you. And